Hey everybody, in this lesson we're going to talk about molar concentration. Molar concentration is the concentration of a solution, and we can use mole concept to help us convert and make solutions. So first of all, we're going to start off with what is molarity? Molarity is defined as the um, the concentration of a solution, and it's the unit of it is moles per liter. But this is for a solution, so that means it's not STP. So that's a big one. It's not STP. So you could call it molar concentration. The equation for it is C, concentration, equal to N over V, where N is the number of moles and V is your volume in liters. And thus, because of that, we have another conversion factor because it's a derived quantity. Now note that the volume here is in liters, not in milliliters. And whenever we put square brackets around a chemical formula, it means that we're talking about its concentration. Now, whenever we write moles per liter, we have a shorter way of writing it. Another way, moles per liter can be represented by capital M. That's another way of representing that unit. All right. So what are some important terms we need to know? Well, the first one is concentrated. When something is concentrated, it means high concentration. When something is diluted, it means low concentration. Okay. So when something is concentrated, it means it has a high concentration, it means it has a high moles per liter. Remember, moles is the number of particles. So if something is concentrated, it has a lot of particles in that amount of volume. If something is diluted, it means low concentration or low amount of particles in that volume. All right. Now let's go into how can we make solutions precisely, and then we'll do some calculations involving that. So to make solutions precisely, we use what we call a volumetric flask. A volumetric flask is a flask that has an accuracy up to 0.1%. That means whatever you make will be only off by 0.1%. And why? Because the meniscus, or the tubing part of the flask, allows only a slight volume change as you go up. And thus, if you measure it to the line and the meniscus touches the line, it's pretty much off by only 0.1% error. Okay, so how do we make solutions? Well, we make solutions by always finding what volume of it you want, and thus how many moles of it you want from that. So like example number one. If you have a 1 liter solution and it contains 5 moles of NaCl, what is the concentration of the NaCl? Well, we know that concentration is equal to N over V. We know N is the number of moles, V is the volume. Thus, we have 5.0 moles divided by 1.0 liters. We're going to get 5.0 molarity. That's the concentration of the NaCl. Okay, but you don't always start with moles. You always have some mass and some volumes. So next thing is, what is the concentration of NaCl when you have 50 grams of NaCl, NaOH, and you have 500 milliliters of it, or you want 500 milliliters of it. So again, C is equal to N over V. We don't have concentration, moles right now, so we gotta convert that first from the volume. We have volume, but that is in milliliters, so we gotta convert that to liters. 500 milliliters is 0.5000 liters. Our first step is let's go find our moles. So we have 50.00 grams. And we have converted to moles by molar mass. The molar mass of NaOH, let's take a look. Sodium Na is 23, O is 16, and H is 1. Our molar mass is 40 grams per mole. So we put our mole on top and our 40.0 grams on the bottom. That will cancel out our grams and give us moles. So our moles will be equal to, in this case, if we plug this in, 50 divided by 40 is 1.25 moles. Now we can solve for it, because C will be equal to 1.25 moles divided by 0.5000 liters. And what we're going to get here is, we're going to get, divided by 0.5, we're going to get 2.5 to 4 sig figs, 2.500 molarity of NaOH will be created. Now this is the example, next example is something in which you will try to do, which is if you know you want to make 4.5 liters of something and you want its concentration to be 0.4 molarity, how much HCl will you need to add to make this concentration at this volume? Well, this is what you have to find. You know that C is equal to N over V. How can you solve for M, the mass? Because here, none of it is mass. Well, to solve it, you have to get to moles, because once you find moles, you can always convert to mass. So how do you get to moles? Moles, N, is equal to C times V. So, the number of moles, N, is equal to 0.400 molarity times 4.50 liters is going to equal what? What is the number of moles here? Well, in this case, you're going to get 0.4 times 4.5. You're going to get 1.8 as your number of moles. 1.8 moles. And now you can now solve for your mass, because you could find the mass of HCl. Well, the molar mass of HCl is, Cl is 35.5, H is 1, so it's 36.5. So you have 1.8 moles times 36.5 grams per mole. What is the amount of mass you're going to need to have in this HCl to make this volume at this concentration? Well, you're going to have 1.8 times 36.5, and you're going to get a mass of 65.7 grams. You're going to need to add 65.7 grams of HCl, then add the rest of it as water up to 4.5 liters, and thus you're going to make 0.4 molarity HCl. The last thing here is, what is the molarity of pure ethanol, which has a density of 0.789 grams per milliliter? Okay, let's take a look. We know that concentration, molarity, is equal to N over V. But density is equal to mass over volume. So we see the volumes are exactly the same, but we gotta convert our mass to moles. How do we do that? Let's take a look. So let's start off with just writing out density. 0.789 grams per milliliter. Our first step is let's convert this mass to moles. We could do that by converting our molar mass. So what is the molar mass of ethanol? C2H5OH. Well, let's take a look. C2, 2 carbons. That's 12 plus 12. Okay. H5, that's 5 hydrogens, which means you add 5 more mass. Plus O, which is 16, that's hydrogen. That's oxygen, 16. Plus 1 more hydrogen, that's 46. So we have 46 molar mass. So how do we get rid of it? Well, we convert it by putting 46.0 grams on the bottom. And we can put 1 mole on top, because that will cancel our grams and get us moles per volume. Hey, we are now almost there. But we need to continue, because we want to solve for moles per liter. So we got to convert our volume to liters. How do we do that? We know that 1 milliliter is equal to 10 to the power of negative 3 liters. That's a conversion you should know. And from there, our milliliters will cancel, and thus our units end up being moles per liter. Let's punch in our calculator. We have 0.789 divided by 46 divided by 10 to the power of negative 3 is equal to 17.0 3 sig figs, 17.2 molarity. And that is the concentration of pure ethanol. So that's how do you prepare solutions or find out more information about solutions. How do you dilute? Or what is dilution? Why do we do it? Well, first of all, dilute means to lower concentration. So when something is diluted, it's a lower concentration. So dilution is to lower the concentration. And the reason why we lower concentration is due to these reasons. It could be to make it safer because it can be dangerous. It also makes it cheaper because you don't have to use high concentration, which costs more money. Alright, so we lower it for these reasons. So because sometimes high concentration can be dangerous to deal with. Say for example you have a high concentration of acid, that is dangerous to deal with. But of course we want to make it cheaper as well. It's lower concentration in this case. And sometimes you just don't need not or no high concentration not needed. So how do we dilute? Well, we dilute in the sense that whenever we want to dilute something, we could do two things. Okay, the first thing is we can lower the amount of moles, right? Because if we look at our equation, C is equal to N over V, we want to lower our concentration. So how can we do that? We can lower the amount of moles. So that means this goes down. But the other way, we can increase the volume. Because if you talk about this, C is equal to N over V, if we want to decrease this, we also can increase our volume. So because of that, we have an equation we could use. Now it's more difficult to lower the amount of moles because if you, for example, have a calculation involved in which you have a solution that you want to make, you can't just take moles out of that solution. It's much easier to increase the volume. But when you increase the volume, the concentration will change, but the number of moles will stay constant. So whenever you dilute, you can keep the number of moles constant. And when you do that, you see that N, or C, is equal to N over V. You could, in a sense, make it in the sense that your moles are going to stay constant. And that's the case, you can write N is equal to C times V. Which means your N initial should equal your N final. If that's the case, then you're going to C initial times V initial is equal to C final times V final. A lot of people call these the dilution equation, where you could write it as, in a sense, your initial concentration, this is the more concentrated one. Well, this, your concentrated final, is going to be your diluted one. A lot of people shorten this to just say C1 V1 is equal to C2 V2. It's much easier to say that than Ci times Vi is equal to Cf times Vf. So what we know is that if we know the concentration we want, or we have initially, and we want to know the concentration afterwards, we just change its volume. And these two will equal each other out. So let's try it out. Let's see what we get. So if 250 milliliters of 0.75 molarity NaCl is added to 500 milliliters of water, what is the concentration of NaCl of the new solution? Well, let's take a look. We have three pieces of number here. Okay. We want to fill and figure out these two information. Okay. C1 and C2, and what's V1 and V2. Well, what's the initial concentration? C1. The initial concentration is 0.75 molarity. Do we know what the concentration afterwards? No, that's our X. That's our unknown. What's our initial volume? Our initial volume of that solution was 250 milliliters. What is our final volume? Well, we had it 250 milliliters initially. We add 500 milliliters of water to it. Our final volume will be 750.0 milliliters. So we have everything. We just got to solve for C2. Because our equation C1V1 is equal to C2V2. C1 is 0.75 molarity. V1 is 250.0 milliliters is equal to X times 750 milliliters. So now our next step is to divide both sides by 750.0 milliliters. Divide both sides by 750.0 milliliters. We're going to solve for X. C2 is equal to, in this case, let's take a look. 0.75 times 250 divided by 750. And we're going to get 0.25 molarity. That means our concentration afterwards is going to be 0.25 molarities, which makes sense. Why? Because, let's take a look at our information given. Initially, our concentration was 0.75 molarity, and we had a volume of 250 milliliters. But afterwards, we diluted it to 750 milliliters, which means that we diluted the volume increased by 3 times. If our volume increased by 3 times, our concentration should decrease by 3 times, which means 0.75 decreased down to 0.25, and that's what we have here. Let's try our next example. What is the concentration of HCl when we have 1.5 liters of original solution and we want to dilute it to 4.5 liters and we want to have our final concentration of 0.3 molarity? Okay, so we have our initial volume, which is V1. We have our final volume, which is VF, or V2. We have our final concentration because that is what we want to dilute to. So we want to find what the initial concentration is. So again, we write our information down. C1V1 is equal to C2V2. You can write it like that. Okay, do we have our initial concentration? No, that's our unknown. We have our initial volume, that's 1.5 liters. We have our final concentration at 0.300 molarity, and we have our final volume, which is 4.5 liters. So we want to solve for our equation C1V1 is equal to C2V2. Our initial concentration is X. Our initial volume is 1.5 liters. Our final concentration is 0.300 molarity, and our final volume is 4.5 liters. Divide both sides by 1.5 liters, because that will cancel and solve for our unknown. And what we're left with is C1 is equal to, well, you can take a look and actually already see it. If our volume initially was 4.5 liters, or 1.5 liters, and we diluted it to 4.5 liters, we increase the volume in this case by 3 times. Which means if we increase the volume by 3 times, our concentration would have decreased by 3 times. Which means that our initial concentration should be 3 times higher than this one. Well, what is it going to be if it's 3 times higher? Well, it should be 0.9. Do we get 0.9 here? Let's see. 0.3 times 4.5 divided by 1.5 gives us 0.900 molarity. Or in this case, should be 2 sig figs, 0.90 molarity is our answer. Our last couple examples we're going to notice is what happens if you mix 2 solutions. These are the same solutions, first of all, so same solutions, but they have different concentration. Let's say, for example, we have 2 glasses of salt water have different concentrations, and we mix them together. What's going to happen to their concentration afterwards? Well, what's going on is when we mix 2 solutions with different concentrations, okay, we are diluting each solution individually. But what we do after that is the resulting concentration will be the 2 solutions final concentration added up. So what that means is you treat each solution as an individual dilution equation and then you add their final concentration up. Let's see what that looks like with this example. So in this next example, if 0.400 liters of 0.2 molarity NaOH is mixed with 0.800 liters of 0.500 molarity NaOH, what is the resulting NaOH concentration? So we have our first solution, and we have our second solution. Okay, so we're going to treat each of these as individual dilution equations. Now when we mix these two together, what is our V2 going to be? It's going to be 1.200 liters because 0.4 liters plus 0.8 liters will be 1.200 liters. Alright, so let's solve our first equation. So our first one is, we have our V1 and our C1 here. Our second solution, we have again our V1 and C1 here. So we're going to treat each one individually. So I'm going to move on with our calculation separately. Okay, so we have so we have C1 V1 is equal to C2. Actually, I'll title it a bit differently. Actually, let's call this one solution 1. C1 V1 is equal to C2 V2. Okay, so in this case, our first solution is 0.2 molarity times 0.4 liters is equal to C2, which we don't know, times 1.2 liters. Well, what we're going to do, divide both sides by 1.2 liters. And what we're going to get is we're going to C2 of solution 1 as, well, you can see, it's going to become 0.2 times 0.4 divided by 1.2. We're going to get 0.06 repeating. Repeating molarity. That's solution 1. Solution 2 is going to be the same calculation. C1V1 is equal to C2V2, but your initial concentration volume will be different because it's going to be 0.5 molarity times 0.8 liters is equal to C2 times 1.2 liters. Divide both sides by 1.2 liters. You're going to cancel out. C2 on this side is going to be, let's take a look, 0.5 times 0.8 divided by 1.2, we're going to get 0.3 repeating. Okay. So our final step is to add these two. 0.06 repeating plus 0.3 repeating is got to equal to, so if I add these two, 0.06 repeating, it should equal, if I round this out, to 0.400 molarity to 3 sig figs, because my lowest number is 3 sig figs. So that's my final concentration when I mix these two. So what do you notice? What do you notice about our answer versus our initial concentrations? 0.4 versus 0.2 and 0.5. You notice that 0.4 is between the two concentrations of our initial solutions, but it's closer to the one that has a higher volume of it, which makes sense because if you have a higher volume of this concentration, it should be, in a sense, the one that is going to be closer to that concentration. So that's what we're going to see. We notice that our concentration is between the two initial concentrations. But our final concentration is closer to the one that has a higher volume. So that's how you always check your work. If you have your answer and you could check, is our concentration between the two initial concentration? Yes, it is. Is our final concentration closer to the one with a higher volume? And in this case, it is. So that's how you always check. As always, make sure you keep yourself safe and healthy, and I'll see you soon.